Let us look at what are Pythagorean triplets. Triplets mean 3. So, Pythagorean triplets are 3 numbers which satisfy Pythagorean theorem. For example, 3, 4 and 5. If we take a right angle triangle with 5 as the hypotenuse, because hypotenuse is the largest and 5 is the largest here, right? And we can take this side as 3 and this side as 4. So, according to the Pythagorean theorem, we know that the square of hypotenuse is equal to square of altitude plus the square of base. So, we'll write 5 square equal to 3 square plus 4 square. Let us verify this. 5 square is 25, 3 square is 9, 4 square is 16. So, this is true. That means 3, 4 and 5, they make Pythagorean triplets. There are many other triplets. For example, we have 8, 15 and 17. Here 17 will be the hypotenuse. So, 17 square is equal to 15 square plus 8 square. 289 is equal to 2 to 5 plus 64, and this is true. Similarly, we have 10, 24 and 26. And if we check, 26 square is actually equal to 10 square plus 24 square. Now, we can have multiple Pythagorean triplets like this, but we cannot keep on doing hit and trial to find out these triplets, right? There must be some easier way out, and there is a formula. For every integer m where m is greater than 1 to m square minus 1 and m square plus 1 are the Pythagorean triplets. For example, let us take m equal to 2. So, 2 into m 2 square minus 1 and 2 square plus 1. These will make the Pythagorean triplets. This will be 4, 2 square minus 1 is 4 minus 1, that is 3, and 4 plus 1, that is 5. So, 4, 3 and 5 here are the Pythagorean triplets. Similarly, for m is equal to 6, we will have 2 into 6, 6 square minus 1 and 6 square plus 1, which will be 12, 6 square is 36, 36 minus 1, 35, and 36 plus 1 is 37, right? So, for every integer, these 3 will make the Pythagorean triplets. Let's verify it as well. Since these are making the Pythagorean triplets, that means this should satisfy the Pythagorean theorem. And if you just notice over here, m square plus 1 always gives us the highest number. That means this forms the hypotenuse. So, if we just apply Pythagorean theorem here, it will say 2m squared plus m square minus 1 whole square should be equal to m square plus 1 whole square. 2m square is 4m square and this is a minus b whole square. So, a square plus b square minus 2ab, and this is a square plus b square plus 2ab. M raised to power 4 will cancel out, 1 will cancel out. We have 4m square. This negative 2m square when it goes on the right hand side will become positive. So, 2 plus 2 will be 4m square, and this is verified, right? So, for every integer m, we can find the Pythagorean triplets using these 3 values. Now, there is one question: what if one of the triplet is given to us and we need to find the other two? So, finding the Pythagorean triplets when one of the triplet is known. Let us start with an example. Let us say the triplet that is known to us is 10. Now, 10 is definitely one of these, one of 2m, m square minus 1 or m square plus 1. Since 10 is even, we can keep it equal to 2m because that would give us m equal to 5, which is an integer, right? And now since m is equal to 5, we can find all the other triplets. It will be 2m, that is 2 into 5 is 10, m square minus 1, 5 square minus 1, which is 25 minus 1, that is 24, and 5 square plus 1, which is 24, 25 plus 1, 26. So, 10, 24 and 26 are the triplets. Now, you must be wondering, since 10 is actually one of these and we do not know which one of these it is, so why did we not put it equal to m square minus 1? We can. Let's try it. If I put m square minus 1 equal to 10, I'll get m square equal to 11. But 11 is not a perfect square. So, this will give me a m which will not be an integer, right? So, I'll have to ignore this. I'll have to cancel this out. Now, let us put it equal to m square plus 1. This will give me m square equal to 10 minus 1, that is 9. 9 is a perfect square, so here m is root of 9, that is 3. It is an integer, so we can find triplets using this. Since m is 3, 2m will be 2 into 3, that is 6. 3 square minus 1. 9 minus 1 will give us 8. And 3 square plus 1. So 9 plus 1 will give us 10. So 6, 8 and 10 are the triplets. This is a valid result and this is a valid result as well. Right? The thing is, this might not work for every case. For example, if I just take 12. Now this is even, I can put it equal to 2m, I get m equal to 6. Using m equal to 6, I can find all the triplets. But if I put it equal to m square minus 1, I'll get m square equal to 13. 13 is not a perfect square, so no integral value of m over here. If I put it equal to m square plus 1, then m square is 11. Again, 11 is not a perfect square, so I won't be getting any integral value of m. So whenever one of the triplet that is given to us is even, we can keep it equal to 2m for sure, and this will give us all the triplets. But what if the triplet that is given is odd? For example, let's say 35. Now, we know that we should not be keeping it equal to 2m because that would give us m, which is a decimal number, right? Not an integer. So, should not be taking it equal to 2m. But if I keep it equal to m square minus 1, I'll get m square equal to 36, which is a perfect square. So, n will be 6. Now, it is an integer. So, let us find out all the triplets. 2m, m square minus 1, m square plus 30. 2 into 6 is 12. 6 square, 36 minus 1 is 35. 6 square plus 1, 36 plus 1 is 37. So, 12, 35 and 37 are my triplets, right? And if I keep it equal to m square plus 1, I am getting m square to be 34, not a perfect square, no integral value of m, right? Now, this is a very much doable approach, but again, this has limitations too. If I just take an example, let's say 7, shouldn't be keeping it equal to 2m, we know this, right? We won't be getting an integer value. If we keep it equal to m square minus 1, I'm getting m square equal to 8. Not possible, 8 is not a perfect square, won't be getting an integral value of m. Similarly, if I put it equal to m square plus 1, m square is 6, not a perfect square, no integral value of m. So this is not a short way. We do not want to keep on trying this for every question, for every number that we get. There has to be a more efficient way to find all the triplets when one is given. And there is. So let's head to that. You must be thinking, why did we just not start with that? Because we should be able to understand why did we have to go and just stick to a formula and follow it. Because we saw that the other methods might give us an answer but might not. In the case of even, gives us an answer but takes us a long process. It consumes a lot of time. So let's look at this. You can also pause the video and jot it down. If m is an odd number, the Pythagorean triplets can be directly given by m square minus 1 by 2 and m square plus 1 by 2. For example, we again take 7, okay, which failed with the last attempt that we did. So here one of the triplet is given, so m is 7, one triplet, it's already given, done. So next will be 7 square minus 1 by 2 and 7 square plus 1 by 2, which is 7 square is 49 minus 1, 48 by 2 and 49 plus 1, 50 by 2. So the triplets are 7, 24 and 25 and we get it. Similarly, if m is an even number, the Pythagorean triplets can be given by m by 2 whole square minus 1 and m by 2 whole square plus 1. Let's take 6. One of the triplet is 6. Then we have 6 by 2 whole square minus 1, 6 by 2 whole square plus 1. This is 6. This will give us 6 by 2 is 3. Square of 3 is 9. So 9 minus 1, that is 8. And this is again square of 3 is 9. So 9 plus 1 is 10. 6, 8 and 10 are the Pythagorean triplets that we need.